Okay, we want to verify directly from the definition that 2 minus x is the inverse function to minus x plus 2. So I want to do this directly from first principles, right? So first of all, let's think about the domain and ranges. We've got to check they all match up, right? So the domain of minus x plus 2, well, that's of course equal to all numbers. And this is a nice linear function. It's going to have the same range. So remember, inverses flip ranges and domains. Similarly, the range of minus x plus 2, same thing, it's minus infinity to infinity. That's equal to the domain of the other function. So I'm just being incredibly careful here, right? So this is going to be my domain of 2 minus x. Okay, so this is the domain. We call this A in the notes. And this is the range. We called it B. So it's flipping them, right? Flipping the range. So that's good. But then we've got to check the actual condition. So what's the actual condition? The actual condition says that we have f inverse of y is equal to x if and only if f of x is equal to y. And this is for any x in the domain of f and y in the range. Now that's a terribly confusing statement. So what we've really got to do is check that both implications work. This if and only if condition is that implies that and that implies that. So I've got to go both ways around. So pretty confusing. So let's do the following. Let's do this side first and show it implies this side. So what's f inverse? Well, that's the potential is 2 minus x. So we've got 2 minus y is equal to x. Let's rearrange this to get y in its own. So this would imply that what? This would imply that take away x from both sides, add y to both sides is equal to that. So that now matches up with this. Brilliant. Let's go the other way around. Well, the other way around is completely obvious. If I do 2 minus x is equal to y, this guarantees just the same exact story. Add x to both sides and take away y. This is 2 minus y is equal to x. So what this has given me is the following. It's really given me the exact statement we're interested in. It's basically verified that according to this notation, fy is equal to x if and only if f of x is equal to y. So in my notation here, so we're kind of jumping the gun with the notation, this is your f inverse of y, and this is your f of x in the notation. So it's difficult to check this. Like verifying something as inverse is something you've really got to wrap your head around carefully. It's not a simple thing to understand.